All right, so today we're going to talk about average rate of change. And this word should be familiar to you because you talked about it in Math 1. It might have been called slope a lot more than average rate of change, but they're the same thing, okay? So first we're going to talk about average rate of change with linear functions, which is the flashback to Math 1, okay? So you already are familiar with the concept of average rate of change when working with linear functions. Okay, so when we were working with linear functions, you were introduced to this following formula. Okay, you were probably more so introduced to the formula, this right here. Okay, but really it's just the difference in your y's over the differences in your x's. Okay, and we say that with change in y and change in x. Okay, and this little triangle symbol right here, that's delta. Delta is a Greek letter, and delta means change in. Okay. And then you're also more familiar with m. You guys correlate m to slope, okay? But it also can be referred to as your a value also, okay, which we have talked about with absolute value functions. Remember we found the average rate of change with absolute value functions, and that was your stretch or your compression, okay? All right, so when looking at a linear graph, when you found the slope, it was your vertical change over your horizontal change, which you most likely heard rise over run. Okay, so when you found the slope of your graph, or the average rate of change of your graph, you were looking at how much did you rise over how much did you run. Okay, so when working with linear functions, you found your slope to be constant no matter where you checked your slope. That's what I want to talk about, is when you were doing a linear function, no matter where you counted your rise over your run. So for this graph right here, no matter where I count my rise over run, it's going to reduce down to 2. Even if I went from here to here, that is, I rose, let's see, you rose 1, 2, 3, 4, and you ran 2. Well, 4 over 2, what does that reduce down to? 2. So no matter what I did, my slope was 2 with linear functions, okay? So I want to find the following average rate of change for the following linear graph, okay? So you find 2 points, 1, and then here's another point, and you count your rise over your run. I rose 1, 2, and ran 1. And so my A, or M, so it's your rise over your run, and it's going to be 2 over 1, which is 2, okay? Now, nonlinear functions. Nonlinear functions, it is the same concept, except your slope will be different with different points, okay? So when working with nonlinear functions, you will find the average rate of change is not constant. It is not constant, okay? Over different intervals, between different points, you're going to have a different average rate of change sometimes, okay? Now, sometimes it can be constant. We noticed with absolute value that it was constant, okay, on one side. Now, the process of computing the average rate of change is still the same, all right? It's the same thing as you did with linear function. It is the rise over the run when I give you a graph. And if I give you an equation or a table, it's your formula. Okay? All right. So, average rate of change for the function, same thing, okay? This is just in function notation, all right? But it's the same concept. It is still y2 minus y1 over x2 minus x1, okay? So, we are going to do different examples. I'm going to break this up into different, we'll say chunks. Okay, so this first video example, we're going to look at equations and we're going to look at applications, and then I'm going to do some problems that look like your Delta math that you're going to do today too, okay? So consider the function x squared plus 3. I want to find its average rate of change in the interval -1 is less than or equal to x, which is less than or equal to 3. All right, so it's written a little different, okay? So this is the interval that I want to find my average rate of change, okay? I want to find the average rate of change between these 2 points, all right? Now, these are your x value points, okay? So I have one x value that is -1, and I have one x value that is positive 3, okay? And now, with the slope formula, or average rate of change formula, it is y2 minus y1 over x2 minus x1, okay? Well, I have my x's, correct? I just need my y's. So I can put my x's down here, and I'm going to say -1 minus 3. But now I need to find the y's. Well, you find the y's like you've been finding y's since you've been missing the y's. Okay, we're going to take that x value, and we're going to plug it in to our function. And here's our function. Okay, so we're going to evaluate this function at -1. Please, 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 when you're substituting, especially negative numbers, please use parentheses. Okay, so we've got -1 squared plus 3. Well, -1 squared is 1 plus 3 will give me 4. So -1's pair is 4. Then it's minus. Now I'm going to plug 3 in, and I get 3 squared plus 3, which is 9 plus 3, which gives me 12. So 3's pair is 12. So now I just simplify the top, and then I'm going to simplify the bottom. So 4 minus 12 gives me -8. -1 minus 3 gives me -4. Now remember, with average rate of change, you need to reduce it, like I did in that one example. So -8 divided by -4 is actually positive 2. So my average rate of change for this interval is 2. Okay? All right. Let's do another one. So consider the function 2x squared minus 4. Find its average rate of change on the interval between 0 and 3. Okay? So again, those are my x values. So my first x value is 0. My second x value is 3. Okay? Let's a little more room. So I'm going to take 0. Well, first we got our formula. Let's do the same steps. All right. I know my x's are 0 and 3. Now I got to find its pair, the y pair, by plugging these x values into this equation. So I'm going to say 2 times 0 squared minus 4. Well, 0 squared is 0, right? And then 2 times 0 is 0. 0 minus 4 is -4. Now let's do 3. 2 times 3 squared minus 4. Well, 3 squared is 9. So I've got 2 times 9 minus 4. 2 times 9 is 18 minus 4. And that'll give me 14. So 0's pair is -4. And 3's pair is 14. Okay? So -4 minus 14 is -18. 0 minus 3 is -3. So then I'm going to say -18 divided by -3, which will give me a positive 6. So the average rate of change on this interval is 6. Okay? All right. So, word problems. Okay? They're not that bad. It's really the same thing we did, except you're just interpreting a few things. Okay? All right. Well, we're not really going to interpret too much today. We're just going to talk about units and stuff like that. Okay? So it says a ball is thrown in the air, has a height of h of t equals -16t squared plus 50t plus 3 feet after t seconds. What are the units of measurement for the average rate of change of h? Okay? So, if you think about it, average rate of change, it's your y's over your x's. Okay? All right. So, my y's here is this. This is my y. Okay? And then this t is my x. So, we want to interpret those units. So, t replaced x, and what does it say your t is? Your t are seconds. So, seconds are on the bottom, because that's where x is. And then it says that your height is represented by h of t, which is y. So my average rate of change units are going to be heights over seconds. Okay? All right. So next, I want to find the average rate of change on h between these two numbers. So again, t represents x. So my x values, one is 0 and one is 2. And we're going to still use that same formula, y1 or y2 minus y1 over x2 minus x1. Okay? All right, so we have our x values, right? So one x value is 0 and the other one is 2. Okay? So I'm going to plug these x's into this formula up here. Okay? And that's going to give me my y values. Okay? I'm going to use a calculator for this one and not simplify it like I did the last one, because I feel like you do less mistakes with equations like this if you just type it in how you see it. So I'm going to type it in how I see it on my calculator. You guys can use Desmos at home. So this is going to give me 3. So my first y value is 3. Now I'm going to substitute x with 2, and I have negative 16 times 2 squared plus 50 times 2 plus 3. I'm going to type it in. Okay. And I get this one to be 39. Okay? All right. So now I'm going to say 3 minus 39, which gives me negative 36. 0 minus 2 is negative 2. Well, negative 36 divided by negative 2 is going to give me 18. Now, since this is a word problem, it is 18 heights per second. Okay, feet. I'm sorry. Why did I say height? That should be feet. Oh my goodness. Your height is measured in feet. So I knew it sounded so weird. It's feet per seconds. Okay, those of you watching who saw that mistake, you should have spoke up. So it is 18 feet per second. Okay? All right. Next one. Says Frank is selling lemonade. The function g of t, I hate that it did that, is this right here, okay? Models the number of glasses he sold after t hours. What is the average rate of change between those 2 hours, okay? So it tells me that t is hours, so my x is hours, okay? And then my y is going to be the number of glasses he sells. Okay? All right, so we got x equals 2, and we got y equals 6. And we're going to use that formula y2 minus y1 over x2 minus x1. Okay? All right, so we're going to replace t with 2. We've got 2 squared plus 4 divided by 2. 2 squared is 4. 4 plus 4 is 8. 8 divided by 2 is 4. So my first y value is 4. Okay? Now let's plug 6 in. 6 squared plus 4 over 2. 6 squared is 36. 36 plus 4 is 40. 40 divided by 2 is 20. Okay? So 4 minus 20 is going to be negative 16. 2 minus 6 is going to be negative 4. 16 divided by negative 4. Negative 16 divided by negative 4 is 4. So he can sell 4 glasses per hour. Okay? Now, you're not going to have a delta math on the applications, but you are going to have a delta math on the equations. So we're going to stop the slideshow. Okay? And we are going to go to delta math, and we're going to do a few examples like you're going to see today. Okay? So this is what you're going to see in your assignment after this video. Okay? So we're going to zoom in a little bit, and then we're going to snip it. Whoops. Okay. All right, so we're doing equation. All right, so we still are using y2 minus y1 over x2 minus x1, okay? So it says, given the function h of x equals negative x squared plus 4x plus 10, determine the average, determine the average rate of change of this function over this interval, okay? So this interval is my x values. So on the denominator, it's going to be negative 4 minus 3, okay? So I need to find its y pair. So I'm going to plug each of these x values in, and please, please, please use parentheses, okay? So first we're going to do x equals negative 4, all right? So if you notice, there is already a negative there. So I write the negative, then you do the parentheses, okay? Plus 4, parentheses, negative 4, plus 10. All right, so I'm just going to type this in my calculator. But you guys can use Delta Math, or if you have a calculator at home, that is fantastic. All right, and I get this to be negative 22. So my y value is negative 22. Now I'm going to do 3. I'm going to come up here and do 3. So x equals 3. I'm going to replace all the x values with 3. So I have negative, parentheses 3 squared plus 4 parentheses 3 plus 10. Okay, I type it in to get my answer. And I get it to be 13. So I come over here and put minus 13. So I'm going to say negative 22 minus 13. And I get negative 35. And then I'm going to say negative 4 minus 3. And I get negative 7. Well, negative 35 divided by negative 7, that is 5. Okay? So my average rate of change here is 5. So when I go back to Delta Math, we're going to cross our fingers, right? So I don't look ridiculous, get the wrong answer. And we got the right answer. All right? So let's do another one. So what I want you to do is I would like you to pause this video. It's the last problem we're going to do, and I want you to try this one on your own, okay? See what you can do, especially before you get to the Delta Math. But again, with the Delta Math, it has a show me solution. Show you the solution if you want to see the written out work like this without, my commentary, okay? It can help you out, all right? So do that problem. And let's go, so pause it. All right, so I hope you paused it. And let's see if you got it right, okay? So my x values are the interval right here, okay? So we're going to use the y2 minus y1 over x2 minus x1. So my x's are negative 5 minus 1. Now I've got to find the y pair. So I'm going to first plug in negative 5. It has another negative on the outside, so don't combine them together. Okay, you can't do that. All right, so I'm going to type this into my calculator. All right, and I get 8. So 8 is the first answer. So now I'm going to do 1. So now I'm going to replace x with 1. Okay. And I get it to be 2. So 8 minus 2 will be 6. Negative 5 minus 1 will be negative 6. So my average rate of change here is negative 1. So I go here, type in. Okay, I'll use this keyboard. Negative 1. Submit. I got it right. All right, so go to Delta Math, do these problems, and let me know if you need any help.